Alright, I guess I'm live. Well, this is the second video that or not video, second time I've broadcasted on Twitch. And if you haven't seen the last broadcast, which probably you haven't, I have it archived on YouTube, and I have a link below to the intro, which is a re-recording of it, and making my own web server in C++. And today I'm just going to kick off some actual development. And the component I'm going to work on is called URI, and the method I'm going to use is called test-driven development. And I can briefly describe test-driven development, maybe make a video about this separately. So it's a software development process that was pretty much, I shouldn't say I have to learn not to say that. Test-driven development was sort of coined, or the term was coined by Kent Beck, and it's a process of developing software where you build your tests first, and the tests also document your code. And having tests for your code is really important because it helps you build confidence. Later, if you make changes to your code, you can run your tests and gives you confidence that you didn't break anything. And if you do find a bug, a good discipline is to make a test that catches or exposes or shows the bug, then fix your code, verify the test passes, and then if the bug ever comes back, which is called a regression, usually it's in the form of your test failing. Eventually, as you grow your software, you also are growing your unit tests, and you end up with a large database of tests, which builds a lot of confidence about your software. So the process is pretty simple. It's a cyclical process where first you add a test for some new feature or component or bug or whatnot. You run the test and see that it fails because you either don't have the code or the bug is still there. Then you write the code or fix the bug. Run the test again to make sure that it passes now. And the steps after that they show in Wikipedia, I guess it's just one step, called refactoring. That's a good idea, but you don't always do this. Usually, for me, when I'm in a development mode, I'm not refactoring. Refactoring is sort of a different mode for me where I'll sit down and instead of writing new code, I'll be trying to clean stuff up, which is also called refactoring. I use the same TDD process, sort of, where you're not writing new tests, you're just changing the code and you're making sure that the tests still pass. But yeah, the whole process repeats, so every time you're done getting a new test passing, you're probably going back in and adding a new test. And you try to stick to a discipline of not changing the code unless it's in order to make a test pass. So you have to resist the urge to go in there and fix a bug if you see it right away before actually setting up a test to catch the bug. So I'm going to start developing this component called URI using TDD. And I have a little README for URI. I already have the library set up. Really quickly, I'll show you there's really nothing there yet. It's an empty code. But I have a README for it, and URI is Uniform Resource Identifier. It's a fundamental component that's used on the web. You might know of it as a URL, but it's in general it's just an address or an identifier for something. And fundamentally, it's just a string. My dog was barking. Whenever my dog barks, I have to quickly hit my mute key. Anyway, let's see, where was I? So URI, fundamentally a string that has several parts, and we need a class in C++ to parse the URI string into its various parts or elements. And I made another markdown here that's sort of derived from the RFC, request for comments, which is a form of internet standard, and you can actually go find it. And not a whole lot of people like to read standards documents; they're kind of dry. So what I've done is I've kind of read through it. I've read through it before as well, but recently reread it and kind of boiled down the information there into what you might want to see without having to read the whole RFC. So let's go over it. Here's the structure of a URI, and I think I took this straight from the RFC. There's the scheme part. So in this example, it's foo, but you might see it as HTTPS or something like that. Then there's the authority part, which is used on URLs to hold the website, and if there's a colon and a number, it's the port number. You might not see a port number. If it's missing, then you use a default. Then there's the path part, which is like a path on a file system to locate files inside of directories. And then there's optional query and fragment parts. And these are used usually by a web server to fine-tune the parameters for a lookup of a web page or a resource. But they're optional. If they're not there, then there's usually either defaults or they're empty. So that's one kind of URI. Another kind that they show in the example is one that doesn't have an authority. And this example, URN, I think it's uniform resource name, where it's not identifying a specific resource. It's more just identifying, or not identifying, but giving a name for a resource. Just an example to show that where the authority is optional. So in this case, it's URN, and it's just a path. Example animal, ferret nose. So that's really high-level overview of what a URI is. And I've kind of listed here what are the key elements, and I'm going to try to map these to our class that we're going to write. So is relative. This is because, I should say, we need a flag called is relative because the standard talks about there being two main categories of URI. There's the absolute, or what they call URI, and there's the relative reference. Relative reference is just missing things like the scheme and the authority, and it's just showing the path. Kind of like a relative path into a file in a file system. So we'll have a flag to indicate if a URI is relative or not. And there's the scheme. If it's not a relative URI, we have the scheme part. There's user info, which this example doesn't show. It's not used often anymore, but in the past there was a provision in a URI to put a username and even a password in the URI string itself. So if we have one, then we'll store that in user info. Then there's the host, which is the host name part of the authority. Port number, if the port number is included. Has port to indicate if this part of the authority which has the port number is included or not. And the reason why we have a separate flag is because there is really no value we can set for port to indicate that the port is not to be included. You might think you could use 0, but 0 is actually a valid port number in URI syntax. So we'll have a separate flag so that if that's true, then we will print the port number, otherwise not. Then there's path, which would be the sequence of path strings. And then query, which is this part here. And then fragment, which is that part there. So special rules that I kind of gleaned from the standard. So path AB empty, that's if the URI has an authority component, the path must be either empty or absolute. That's because if you try to use a non-absolute path with a URI and with an authority, it's ambiguous. In other words, if we had removed that slash there to try to make it a relative path, then you could parse the rest of the path here, or at least the first word of the path, as part of the authority name, especially if the port number was missing. In other words, if I can't show it right there, but let's go to a new file. If we had like http example.com/foo/bar. Now if we removed the slash to try to make it a relative path, now it looks like example.confu, so it's ambiguous. So to disambiguate it, the syntax requires that if you have a URI with an authority, it has to be absolute, which would be this one, or empty, which would be this. That's an empty path. As opposed to that, which is a path with just one element, which is an empty element, which signifies the root. So we'll say that this is URI with authority and path, which is absolute. This is a URI with authority and no path. This is a URI with authority and a path of slash, which is absolute. I'll say what the path is here. Foo bar. And this is a URI with authority and path of bar. We mint authority of example.foo, example.com, and path of foo.bar, but this isn't allowed by the syntax. So those are the examples we've gone through so far. Probably keep this document to show examples. Alright, so the next special disambiguation rule is the path no scheme. That says that a relative reference cannot have a path whose first segment contains a colon. Otherwise, its string would be ambiguous. It would also match a URI whose scheme is part of the first segment of the path. So let's show a relative reference. Relative reference would be something like, let me think about this. Foo slash bar, right? Now, if you had a string of foo colon spam slash bar, that's ambiguous because that's actually a URI with authority of foo and path of spam slash bar. Oh, sorry, I paused because I just realized it's not authority, it's scheme. Problem is it's ambiguous with the URI whose scheme is part of the first segment, right? So what we meant no scheme. In other words, a relative reference and a path of foo spam bar. So this is ambiguous. Also mark the other one that's ambiguous. Alright. So those are two special syntax rules we have to be aware of that prevent ambiguous URIs. Okay, and some notes that I took when I was reading through the RFC. An empty string properly indicates that it isn't included in the reference. So, for example, if scheme is empty, oops, didn't mean to do that. If scheme is empty, it means that there isn't a scheme. Host being empty, there is no host, etc. Now, second note, I think I mentioned this before. A zero port number is still syntactically valid, so we need a separate has port property to indicate whether or not to include the port. So in general, if we have a non-string property, we're going to need a flag if the property is optional in order to indicate if we're going to include that property or not. Note number 3, authority component is only included if the host is not empty, regardless of whether or not user info is empty and regardless of has port. That's because you can't include, to say authority includes the host, port, and user info. And so if all of those are empty, like host is empty, hold on, I'm not understanding this correctly. Let me read my note again. It's only included if host is not empty. Right, you can't have an authority with a port number but no host. That doesn't make sense. So as a shortcut to whether a flag that indicates whether or not to have the whole authority or not, I'm just going to use the fact that host is either empty or not empty. If it's empty, we're not having any of the authority component. If it's not empty, then we have the authority component, which would be the host, possibly with the port number, possibly with user info. Alright, so last note is if the first element of the path is an empty string, it indicates that the path is absolute. So back to our examples right here. This first example, It's an absolute path because if you think of the slashes as separators between components, this has three components. So the path is, if I were to say this kind of syntax, it's empty string, foo, and bar. That's the path. And here's another example. The path is just empty string. Here, this relative reference, it's foo bar. In other words, it's not an absolute URI, it's a relative URI, hence relative reference. And let's just, for completeness sake, we'll put down here what the path elements are. I think you can see what we're getting at. We're going to be parsing that path string into a list or an array of the elements of the path. And I designed that on purpose because if you think about what a path is, it's a sequence of steps down a hierarchy. And in our web server, we might have one step called foo, and we want a piece of code to be in charge of that domain, so to speak, or that area of our resource hierarchy. So the first part of our path might be taken by our web server to figure out what code to call, and it would say, oh, foo, okay, I know what code to call for foo. And then the remainder of the path, which would be that bar, would be given to foo as, well, here's the rest of the path. You figure out what kind of sub-resource or part that's being referenced. So we're subdividing the path into the part that leads us to the code, and then the rest, which would be arguments. All right, so the rest of the notes I have here are a copy-paste of all of the raw syntax from the standard. I did this more for my own reference. And I don't think I'm going to go over it right now because it's pretty dense. Let's get straight into the coding. So, following TDD, I have set up a unit test suite here, which uses Google Test. And I talked about Google Test in the last video. And so I'm not going to go over it again. But it's pretty easy to understand. We're going to have what looks like a function, and actually is a function, but with a name that's actually a macro. The first argument of the macro is the name of the suite, and the second is the name of the test. And I will be able to run my unit tests on the command line by going to the build directory, and then name of the component, see if I remember this right, test, debug, and then URI test, right. So here we see URI test, the suite.placeholder. And when we have more tests, we might find it's convenient to do gtest filter. So let's say we'll run all the tests that start with URI. Or we might just run the specific test placeholder. It makes more sense if I had more tests. It would show that it's only running a subset of our suite. So I have this placeholder here. We're going to actually remove it and replace it with a real test. I just had it in here to make sure my build system was right. So let's consider what we want the class to do. Well, we're probably going to want to take a string and parse it into its various elements. So let's call our first test parse from string. And here when we're going to write the code, when we're going to write the test and the code doesn't exist yet, it's okay to write code that won't compile. In fact, that's even before the test fails, the pre-check is that the code won't compile, and we'll have to do some coding to make it compile, even if the test fails at first. And at this point, I actually might switch over to Visual Studio proper. I'm using Visual Studio Code because then I can get a little bit more of an IDE environment. So let's do that. So in the build directory, excalibur.solution. Hopefully this runs. Last time I was running Professional Edition and my license expired. And so I had to flip over to this Community Edition. And let me change the color so it looks a little bit nicer. If I remember how to do this, tools, options. I don't remember, so I'm gonna just type it in here. And yeah, they're up. Oh no, it's frozen. Okay, we want dark. Yes, dark theme. And we're going to make it a little bit bigger for you guys. Should be pretty good. Alright, so parse from string. We're going to make our URI. And we're going to say assert true that URI.parse from string. And we'll have a nice little example URI here, http www.example.com/foo/bar. And I'm thinking what parse from string will be is a method of the URI class that takes a string and then returns a flag about whether or not the URI string was valid, syntactically correct. And if it is, we're going to then inspect it to make sure that it parsed it correctly. So we'll assert that equal, which means that we're going to compare two things. And I like to do expected comma actual. So we expect HTTP for the actual URI.get scheme. And we'll assert that the host is www.example.com. URI.get host. You can see all the squigglies because it's not even going to compile because we don't have methods like parse from string, get URI, or get scheme and all that stuff. We'll fix that in a moment. So the last part of this URI was the path. Here's where it gets a little bit interesting because I kind of want the path to be a list. So let's see if I can do this correctly. If I remember right, Google Test wants me to give it a type. And our type will be a vector of string. We're going to use list initialization syntax here. And I think it also wants me to put this in parentheses. The list will be empty string, foo. The editor's fighting me a little bit about the indentation, but that's okay. And then bar. And put an extra comma there. And just as an aside, I end up putting a comma even after the last element, because if later we added another string like this, in version control it'll show up as only this line added, and we won't have to touch the line before it, which is kind of nicer and cleaner, I think. Anyway, so we're going to assert that URI.get path is going to return us a vector of strings with these three strings in it. And then we don't need this placeholder assert true anymore. So when we try to build this thing, we should get some errors. And okay, we got the solution refreshed probably because CMake decided to rebuild the build system, which is fine. Build again one more time. So we get the same kind of errors like we expected. There we have no get scheme, no get host, no get path. So we will go and fix that now. Going to first add it to the header file. Parse from string, right? All right. So it's going to return a bool. It's going to take a string, and which is the what do we call it? URI string to differentiate from the URI itself. Okay, string not defined, so we will pull in that part of the standard library. How long have we been streaming? Oh, already 25 minutes. Okay, the green squiggly means there's no implementation yet, by the way. So I like to document right away, otherwise I get lazy and I forget. So we're going to document that this method builds the URI from the elements parsed from the given string rendering of a URI. And the single parameter, which is input only, is the URI string. This is the string rendering of the URI to parse. And what we return is an indication of whether or not the given the URI was parsed successfully is returned. Alright, and then we have, you can see right now the red squiggly went away because we have declared the parse from string method. So next is get scheme. It's going to return a string, get scheme, get scheme. And just for the kicks, we don't really need this all the time, but if we know a method isn't going to change an object, it's kind of polite to give it const. That way, if someone has a const URI, they can still get the scheme without a compiler error. Okay, this method returns the scheme element of the URI. The scheme element of the URI is returned. And it might be a little redundant, but I think it's generally a good idea to not, how do I say this? It's not bad to be a little bit redundant when you're writing formal documentation, and I'm just in a habit of doing it this way. And I might have mentioned this before in the previous video, but this syntax for writing a comment to document a function is based off of Doxygen, which I think is based off of JavaDoc, sort of a standard way of documenting functions. So special return value of empty string. This is returned if there is no scheme element. In the URI. Alright. So we're going to want to do the same thing for the host. Yes, the host, and then get path is going to be different. So the host element of the URI. Path is going to be vector. Oh, it does that if we haven't yet included the vector API. It tries to auto-complete it to something else. So we will fix that right away, include vector. If you haven't figured it out, I like to minimize the number of includes. Just include what we need. Let the compiler tell me if we're missing something. Need to set up my preferences in Visual Studio. Kind of getting annoyed with auto-completion here. Let's see. This method returns the path element of the URI as a vector. Let's see. I want to kind of talk about how what it's returning isn't just the whole path string, but it's like the elements of the path in a vector. Not the, I shouldn't use the word element, the steps of the path. This method returns the path element of the URI as a sequence of steps. And then we're going to actually put a special note here. If the first step of the path is an empty string, then the URI has an absolute path. And there's no parameter. We're just returning the path element. Path element of the URI is returned as a sequence of steps. Alright. So at this point our unit test should compile, but it's not going to link because we have not implemented those methods. That's what we expect to see all that. I wonder if I can make this bigger too. Don't know how to make that font bigger yet. Hold on a sec, I'm checking some off-stream things. Alright. So let's implement those methods. Let's grab get scheme, put it in our implementation file. Might be a faster way to do this, but the way I do it is worked for me for a while, so probably continue to do this until someone schools me in how to do it faster. Just copy pasting from our header, adding a body, adding the class name in front. All right. So this isn't going to compile because we have to return a value from these. So let's just do the minimum. That's sort of a theme of TDD, is you do the minimum to get it to actually build, and you'll expect the test to fail, and then you go fix the test. Fix the code to make the test pass. All right, so parse from string. I forgot about that one. Try to keep it in the same order that it's declared. Yeah, return, I don't know, return false. Default value for bool. Right, so it builds, but it's not gonna run. Oops, wrong. Ran the wrong thing. Oops. Cancel. Okay, close that guy. All right, run the tests with no filter. All right, our test fails. It failed on line 14. Line 14 was parse from string, so let's fix parse from string. So, this might seem silly, but the way I was taught TDD is you do the minimum to make the test pass. And if the code still isn't doing what you want, then you haven't described the test well enough. So if we just had the test assert that parse from string is returning true, hey, I know how to fix that. We just return true, right? So if that's all our test did, we would actually pass the test, but it would be a bad test. We're still going to fail because the next part of that test asserts that the scheme was HTTP, right? So parse from string returns true, but then later get scheme isn't returning the correct thing. Well, let's fix that, right? Shall we? Okay, get host needs to be example.com. Right? And path needs to be that path that we have in our test, right? Hey, our test passed, right? That means our tests are good. No, we just cheesed it. So we learned from that our tests do not completely describe what we need it to do. Now you could take this to a silly extreme and always try to cheese your tests, but and I'm cheesing it a little bit more than I usually do just to illustrate. So I usually don't go to this length, but wanted just to do so on the first try. So given that we're going to try to cheese it, a good way to specify it a little bit more is to have a second round here. That we're going to parse a different kind of string. Let's do a URN. Well, let's pick a name of a book. What did I have in my, let's see, in my README? Actually, not the README, it was in the notes. Right, there was a name that was going from general to specific, so we'll do the same thing with a book. How about that? Oh, that's because I was in Visual Studio. All right, URN book fantasy Hobbit. So there we assume that the scheme is URN. We're going to assert that there is no host. And the path is book fantasy Hobbit. What happened here? Oh, yeah. Doesn't quite like or understand my indentation scheme. Oh, fix that too. So now our test is going to fail, and now it's not something that I can easily cheese because we need it to return a scheme of URN for the second example, but HTTP for the first. And when it gets to the point where it's harder to cheese it than it is to write the real code, that's you're in a good place with your unit test, which is pretty much where we are now. So I wouldn't normally overspecify the test like this. I might have just stopped at the first example and written the correct code that does what we want and pass the test. But this is it's good to show you an overspecification the first time we do it so you can get the point. So now we can't cheese it. We're going to have to parse it and at least get these three elements of it. And we can skip the rest for now. We'll write tests to capture the other elements later. So how are we going to get the scheme out of the string? Well, one convenient aspect of URIs is that if there is a scheme, it's going to start with a string followed by a colon. So what we can do is say URI string dot find is probably good enough. Find a colon, and we'll call that delimiter. All right, so it'll be the string up until that delimiter. So I'm already thinking ahead of what I would need to have logic to check, but strictly following TDD, all our examples have colons in them, so we are good to just assume the worst, which is that there will always be a colon, and we'll make a test later to fix that bug. So we're actually putting in a bug on purpose here, just to be strict to TDD. We will make a test to fix this bug later. It will be assuming that the limiter actually is in the string, then the scheme will be the substring of URI string. Substring beginning at 0 and going to the account of delimiter characters since we're counting from 0. So to get that from one method to the other, we use state. So we're going to introduce a new state variable. Say this is the scheme element of the URI. Maybe not the best comment because it's sort of self-evident, but that's what we're going to say for now. Technically, standard string is pulled in by URI.hpp because it's used as the return value for some methods in our API. So I don't have to include string, but I like to do this just in case later we change the API of URI to remove string, but we're still using string internally. So to strongly couple the fact that we're using string in this implementation, I'm going to include string here, even though we didn't really need to. All right, now that scheme is in our state, instead of making a local here, we'll put it directly in our state and then return it here. Now our test should pass the scheme check and it gets to the host check. So now we need to worry about the host. So going back to our example. Where's our example? Right, our example here. Here's the delimiter. This would be the rest of the path. So we see what we need to do is we need to check if there's 2 slashes. And here's where you can kind of get an understanding of why there's 2 slashes in that kind of URI. If there was 1 slash, it would actually look like scheme with no authority and just goes to an absolute path, right? The 2 slashes make it clear and unambiguous that the next part of the string is the authority, not part of the path. The authority being the host name, port number, user info, and all that. So what we're gonna do is we're gonna take the remainder of the string, and if it begins with 2 slashes like that, then we know it's got an authority, and we're gonna parse the next part of the string for 3 things: host, port, and user info. Now our test only checks for host, so we're going to keep it host. We're going to assume the whole thing is the host for now. then fix it later. And let me think about this. Yeah, so we do need to scan for the 2 slashes because we already have a test where it's going to fail if we just assume there's 2 slashes, because this one doesn't. Right? So we'll say if URI string dot substring from the delimiter and then 2 more characters, if it's // then we're dealing with a URI with an authority. I need to fix that auto type thing is not set up right for me. So in the case of it having an authority, in our example, the authority ends with on the next slash after that. So we'll say, here's where we're going to have 2 delimiters. I'm going to have to be more specific. Let's say authority end. And we'll call the other one scheme end. Authority end is URI string dot find single slash starting at the scheme end plus 2. Now we can extract the host. Oh, we haven't declared the host. Now let's do that. So add our host here. Host is URI string dot substring scheme end plus 2 up to the authority end. But since it wants a count and not an up to, we have to take that and subtract from the beginning of the string, right? No, the beginning of our substring. Otherwise, the host is empty, so we're going to clear if it had something before. Now, hopefully our test will pass, the host part at least. And it didn't. Let me try to think about what happened here. So it got empty string. Oh no, it expected empty string. Did I write that test wrong? No? Oh, it got to the second example. And it expected empty string, but it got example.com. And let me try to think about why that would happen. Because it went to the else and it should have cleared that. Already I'm stumped about why that happened. Well, this might be as good a time as any to show the debugger in action. So the properties of URI tests under the debugging, we're going to make sure that we focus on the specific test. There's only one test, so I really don't need to do this, but good a time as any to show this example. This test was called parse from string. Okay. Now we'd set a breakpoint in our test right before parse from string of the second example, because that's what we want. That's what we actually want to test. Hit F5. We're going to step into that, and because it's stepping through the standard library, we have to step out and then back in until we get to our method. I've heard that Microsoft's going to make that a little bit cleaner in the future. Anyway, URI string is that second example. Scheme end is correct. Scheme is URN. And here's where it should have cleared the host. So I think I see the problem. I didn't actually return impl host from get host. So it parsed it correctly, but it returned a fixed string instead of the real host. Alright, so that should have fixed our... Okay. Now it failed earlier. And it's returned that the host was empty from our first example. So, still in our debugging mode, so we'll start over and go to that first example. Scheme in is that fourth character, scheme is HTTP. Okay, so the substring of URI starting with character 4 and going 2 characters should be 2. Is that correct? Actually, it's not correct because starting from character 4 will be the colon. 0, 1, 2, 3, 4. So we actually need to skip the delimiter itself. So it's the end, which is the beginning of the delimiter, plus 1. And which means skipping 2 more, it'll be 3 instead of 2. And these 3 places. Alright, so now we got to where the path isn't matching correctly, and we can't cheese the path anymore. So avoiding the bug that we had before, instead of hard coding the path, we're going to return the path from our state. Let's add the state. Path, and it's a vector of strings. Let's make sure we have vector included. And we'll also put the same note here that we had in our API about path, that it is, where is it? A sequence of steps. Right. So we're going to have to parse our path. And here's where, when we're doing multiple things, 2 things we can do. So probably the best thing would be to break this up into separate functions. And we could do that now. Separate functions would be parsing the scheme, then parse the host, then parse the path. Or for now, because I'm lazy, I'm just going to put it in comments, and later we can refactor this to split the code into separate functions. For now, we'll just comment saying, first parse the scheme, if any. Next, actually, instead of saying if any, we'll be specific that we're assuming there's always a scheme, right? No, next we'll add a, or later we'll add a test for when there is no scheme. Next, parse the host. And then finally, parse the path. Parsing the path is going to be a little bit more interesting. Before I do that, because I'm already looking ahead, this substring is getting a bit complicated because we need to skip the parts that we've already parsed. So what I'm going to do at this point is introduce another variable that's going to be constantly changing through our function. It's going to be called the rest, or rest. And it's going to hold the rest of the string past the part we've already parsed. And it'll have the general rule of it's going to be the substring of what we one past what we parsed up to the end. We leave off the second parameter, that's exactly what it does. Then we can simplify this process here. Instead of saying scheme in plus 1 plus whatever, actually we want 0, sorry. We want rest here. We use the rest instead of the original URI string everywhere. And we can just say 1. It's 2, right? And then authority n minus 2, skipping the // part, and then rest equals rest.substring authority end. It's not, yeah, authority n plus 2. So the rest is going to be basically the path, but with slashes. So we're going to find all the slashes and break up the vector strings by those slashes. So let's think of a nice way. We're going to need to have a loop. Probably the best is to just chop off path segments. So while the rest is not empty, we will find the path delimiter by searching the string for the next slash. And here's where we do have to be careful about if we don't find it. If we don't find it, then we want the rest of the string. So we're going to be pushing onto the path. Push back. Actually, let's use in-place back to do placement construction. In-place construction. So the rule with in-place or in-place back is that the arguments are the same arguments you would give to the constructor of the element, in this case string. So what does string take? It can take beginning end syntax, so it would be rest.begin and rest.begin plus path delimiter. But that's only if the path delimiter is valid, so path delimiter being a size. When find doesn't find the character in the string, it's going to have the special value of npos, so we'll need to check for that. String npos. So we want it to actually grab all the way to the end of the string, so it will be path delimiter is just the size of the string. Actually, it's better to do length. And here we need to be able to change it, so remove the const. So the rest is again going to be rest.substring path delimiter +1. That should grab all the way to the end. Let's make sure that that worked. It did not work. We got an exception. Awesome. So let's run that in the debugger. Don't see my debugger tab. Let's find that. Find debug. Those breakpoints. I want to put that there so I can delete that old breakpoint. We'll just run it until it crashes. And it did not crash. Probably because we have it set up to not catch C++ exceptions all the time. Let's have it catch them all the time. Run it again, and there we go. Out of range. You can look at our call stack to see where that happened. In our code, it's there. All right, so I guess in this case, it's rest has just got bar in it, and we're trying to go starting from the character position 4, which is off the end. So we will need to do a check. Substring is not nice enough to simply give us an empty string if we go try to grab past the end. So let's do that. I'm thinking ahead. If the string ends with a slash, we do want an extra path element, which is just an empty string. So we really don't want to stop if the rest is empty. We want to do a do. We need at least one element, right? This is right. No. We need to handle examples such as slash, empty string, something that ends in a slash, and something that starts with a slash. We want that to be empty string only, right? Meaning a root directory, we need that to be completely empty. Or having no path, we would need that. We want that to be just foo, and then an empty string. We want that to be empty string foo. So let me think about how we're going to do this. So actually, what we had before. No, what we had before isn't correct either. The only time we want there to be no path is if it begins with a completely empty string. So we'll say if rest not rest empty. I might be doing this horribly wrong, but I'll learn through my failures, right? So if not rest empty, we're going to do it at least once. Think. Probably should stop and think how to do this without just blindly typing. So let me actually stop and think if I'm doing this stupidly. We're going to go through... Right. Should probably make unit tests for these 4 cases, by the way. I'll do that later. What I'm thinking about is handling this one first. This should be good, because it won't go into the if. This, it should at least go through once and end up with an empty string as long as we... Yeah. This will give us an empty string. We have to avoid doing that if we're at the end of the file. I mean the end of the line. How about this? If there... We'll have 2 code paths here. If it goes to the end, we can actually make this a lot simpler. Path, we don't need the path. We'll just say that to push back the rest. If there is a delimiter, then we're safe to use it to get the rest after this element. So that first case should work. The second case should work too, because it'll at least go through once, and actually it'll find a delimiter, but insert an empty string. Then rest will truly be empty, and we'll leave. Third case, it should grab foo, and I see the problem. It's gonna escape back out again. This last one should work because first loop will get empty string, second loop will get the rest of the string. So these first 3 should work, but this last one won't. Get that last one to work. I think what we want to do is we want to check after we've let me think about this. If we find a delimiter, we're gonna want to go through at least one more time. Right? Gosh, my brain is stuck. I think the key is we don't want this to be a do while. Do while is usually not a good idea anyway. Maybe a better way would be to treat this empty one as a special case. Yeah, that's what I'll do. And then we'll have this up here. If it's completely empty, then the path is... Actually, we're going to want to clear the path anyway. Clear the path. Then I can go back to this. So now we don't need to deal with that empty string case, because it's just going to be empty like we wanted. And I guess we do want to do while after all, because we're going to want it to go at least once. Oh no, it's still going to have a problem there. Actually, what we want is only when we get to this case here, where there is no delimiter left, we want it to break. And we can make this an infinite loop. Maybe not the cleanest way to do it, but we'll ultimately get to a point where there's nothing left in the string, there's no slash, and whatever was left in the string, we push back into our path and we just break out. Otherwise, we're going to constantly be chewing off up to the slash and putting what's after the slash back in and looping. I think that should work. I was going to make a test case out of this, so let me put that back in there. Make sure that this builds now. Failed. Chopped off the F in foo. Okay. Let me think about why that happened. Actually, chopped off the slash as well. Oh, probably because the rest is not correct. So, did I do this correctly here? Find the authority end. Oh, it's not +2. The authority end is the single slash, so it's just a 1. Almost there, so the initial slash is being cut off. Ah, I think I know why, because this was wrong here. Right? No? I'm not sure, it's just quicker to debug, so we'll do that. Alright. So rest. Chopped off this scheme. Now this should get the host, chop off the host, and oh, that's what we chopped off too many characters. See that again. The authority end is 17. Okay. How many characters are in www.example.com? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15, 16, 17. So right, that oh, right. We want to include the slash. If there is an authority, it has to be an absolute path, so we don't want to skip that delimiter. That's the trick. Alright, so our first example passes, but our second one doesn't. And it's because I made a wrong assumption. I'm assuming that in our second example that these colons are path delimiters. Really, they're not. Not in most URIs. Actually, there's two things we could do. We could configure the URI for a path delimiter and then allow these colons to be path delimiters, or we can just leave it fixed as slash. I'm actually inclined to allow it to use colon as a delimiter for the paths. Let's do that. So what we'll do is we'll tell it to parse first, and we'll expect that the path is just one element. Let me copy this. I'll do this actually twice here. And my formatting is screwed up. Fix that. Fixing my indentation. All right. So the first time we'll make it's going to have the default as slash, so we'll have one element, right? The second time what we want to do is before we parse it, we'll do set path delimiter to colon. Right, so we're going to need to declare that. Probably want to declare it before parse, just to make the sequence of methods sort of be in line with the sequence that you would use it. So set path delimiter. Do we want a single character? We don't really, because we might want to allow a multi-byte character. So we'll do a string. Path delimiter, or we'll call it new path delimiter. This method. So it sets the character sequence or character sequence that should be interpreted as a path delimiter. Right, and although it's a little bit redundant, we'll say the same thing again. That this is the character sequence that should be interpreted as a path delimiter. All right, declare it. Now we'll define it. And we're going to want to store it in our state because we're going to use it in our parse function. And let's see, kind of want it separate our configuration from our state. We'll put our configuration first. Be, again, a little bit of a redundant. Say the same documentation there. This is the path delimiter. It's going to default to /. Now, wherever we're using this path delimiter, we're going to want to replace that with path delimiter. And I think that should work. We have to be careful that the path delimiter might be more than one character long. I think that is correct. I think so, yes. And we're going to want to use it again here. Here's where we got to be careful. Instead of adding 1, we have to add the length of the path delimiter. And I know it's not going to compile because we used character in our test instead of string. Let's fix that. We'll probably add another test for multi-character path delimiter. Let's do that next. This should pass now. Yay! Now our test is getting a little bit long. Let's refactor this right away, and we'll make different parse from strings. First one will be parse from string URL, and it'll just be that part of the test. And we'll make 2 more. We'll make parse from string URN default, where it's the default. Let's be specific here. Default path delimiter. So there, we actually need to have a URI, don't we? There we assert that the default is we get just the whole string as one path element. Now, need to fix that. I will fix that before I stream next time, definitely. Second test we want is with colon path delimiter, or how about single character? Because I know we're going to want to make another test for a multi-character path delimiter. In fact, let's do that right now. Multi-character path delimiter. Here, let's say, I don't know, how about do that? I don't know if, is that valid? It's not valid in a URI, is it? What's valid in the URI? How about 2 slashes? Why not? And then what we'll do is to try to make it break, we'll put a single slash in there, and now we get to assume, or not assume, now we get to verify that we are allowed to use a single slash in there, but the double slash will be interpreted as a delimiter. Actually, we got to be really. I can't use slash can I, because that's misinterpreted as a as there being an authority. So yes, so need to not use slash, but how about slash dash? And we even have a dash there. So neither a dash nor a slash will count. And let's do a dash slash middle of that one. That is how it ought to be parsed. We did it right. Yay, first try. I forgot to mention that before. One thing that it's valid to do, but you don't always do it, is if you end up writing more code, in this case the supporting multi-character delimiters, more code than you had a test for, and you're like, oops, need a test for that. It's okay to, in fact, you want to do it right away if you see it. It's okay to go into your test suite and add a test to cover the extra code you just wrote. And it's okay if it passes right away. If you're not sure, you might make the test a little bit more strict or broken just to make sure that you did it right. So, for example, I could make it break like that, and then I'll expect it to parse it a different way, and we can say, oh yeah, alright, so it really is working as long as our test is valid. What you don't want to do is when you see a test pass right away to assume that the test is correct. The test you could do something stupid like, what could you do stupidly? You could say if true or if false. So you did that and you weren't watching close enough. And in fact, I will break my unit test there. That will actually pass the unit test, but obviously I've broken the test there. So it's a good idea that if your test passes right away and never fails, to break the test on purpose to make sure the test isn't borked. Anyway, now we have successful parsing of scheme and let's see, what do we do? Scheme, host, and path for URIs. Oh yeah, I was going to make test cases for these. Let's go ahead and do that. So we'll make a test that's focused on corner cases, path corner cases. And because we're going to have a bunch of them, just for convenience, we'll set up our test vectors up front. So we'll say it's a const standard vector of strings. Test vector is that, and I'm using initialization list syntax here, by the way. In fact, I don't even need the equals, do I? I can say these test cases that we wanted. Just change the syntax around here. The type, we're gonna have to fix the type. See if I can search replace on this block here. What I'll do is replace that with that, and that with that, and space arrow with comma. That's close enough. Now we just add the missing brackets here. And let's fix the type here. So the type isn't really that, it's really a vector of structures. And yes, we'll have to make a structure. Struct test vector. Actually, a better way to do this would, let me think about this. This is good enough. Define a test vector where we have path in and vector of string path out. Alright. So now we're going to, for each of our test vectors, we're going to make a URI, assert that we can parse from the string the test vector path in, and then assert that what we expect, which is test vector dot path out, is the same as the URI dot get path. All right. Now that might pass right away, so we'll have to. Oh, it didn't pass right away, and actually we had a bug. Okay, here's an example of where we don't really know which vector failed. So what we'll do is when we shift. This is called shifting in or out. Shifting out. We'll shift out a index that we will be starting at 1, or let's start at 0. Index, and then at the end is fine. We'll increment it at the end. And I like size t for counts. Size t isn't part of the language by default, so you have to include it in standard def. A lot of times you can get away not including standard def because the compiler will include it for you, but I like to be pedantic. Alright, so Now it prints out a 1, so it's this one, index 1. So a single slash is coming out as 2 parts. I think I know why that is. And it's a good thing we have a test for it now, isn't it? So if it's a string with a slash in it, it's going to go through and pull it off. I see the problem here. It's in order to handle this case where we want it to have an extra element. It thinks that there's an element before and an element after. Actually, technically that is correct, right? Maybe empty string. No, we want the first element to be an empty string if it's an absolute path. Otherwise, it's the first real element. This is really a special case, isn't it? Where the first element is empty. The first element is empty. Right. First element is empty, we do want an empty string. If it's not empty, we don't want an empty string. I see that, yeah, the special case really is that if it is just slash, we want only one path element. We're sort of combining the meaning of the slash before and the slash after. So it really is a special case, isn't it? And how do we handle that? Probably the way we handle that is we don't want to break. No, we do want to break if it's empty. If the rest is empty and the element itself is empty, right? So if we kind of just want a special exception at the very beginning, don't we? Kind of don't like doing this, but we could say if rest equals path delimiter, then our special case, else, if it's not empty, our special case is that the path has just a single empty string in it. I don't know if I like that. We might actually want to put a note here. Special case of a path that is empty, but needs a single empty string element to indicate that it is absolute. Starting to make me think that instead of making the first element empty to indicate absolute path, we should just have a flag. Think about that, revisit that later. But anyway, test should pass now. Might be a good time to check this in. Let's check it in, shall we? Oh, over to my Git window. URI. Oh, actually, this might be a good time to point out something I was doing in VS Code. So I found this plugin for VS Code called GitLens. Because why am I looking for it? Because the default version control integration is pretty silly in what revision and what Git repository it's looking at. Like, it should know that if we're in this file, it should be looking at the URI directory, but it's not. It's still looking at the root. GitLens lets me look at all of them, and here I can see that even though there are no changes in the root, there are changes in the URI component. And we can actually click on them and see we've mostly just filled in the body here. One thing that I wish that GitLens did is allow me to just make a commit straight from here, but I can only know how to make a commit using the built-in VS. Oh, hey there, Platao, oh, Pequeno Planeta, that's a very long name. So yeah, I'm not going to make a commit with VS Code. Just go back to the tried and true command line here. Get GUI. Make that a little bit bigger. So this is our first main check-in. Going to be saying a lot here. Just reviewing what we did. So kick off URI component. We're going to list can now parse URIs from strings. This supports scheme, host, and path. And path separator defaults to single / but may be customized. Alright, let's stage all that and commit. And push that upstream. Done. Make sure it didn't change anything else. Oop. Alright, so this might be a good stopping point for me. I'm trying to work myself into doing streaming. I've gone about an hour and 20 minutes and trying to work myself up to where I can do this for hours on end, but since this is my second time I've streamed, I've only gone an hour and 20 minutes and my voice is already worn out. So apologize if I cut this a little bit short. I guess I can talk about what we did and what I'll be doing next time. So we started with an empty class for URI, and we actually filled it in so that now we have a class that can take a URI string, and I should show it from a Visual Studio perspective. We have a class that can parse a URI and get us a scheme and the path and the host out of it, and it handles a bunch of different corner cases. It handles multi-character path delimiters, single character, custom delimiters, as well as checking that the default / does the right thing. So we actually did quite a lot. Next time, if we go back to our README, not our README, our notes. So next time what we'll probably want to get into is parsing the query and fragment parts. And maybe get into the port number, part of the authority, and maybe do user info. And once we have all those basic things, we'll be able to parse any valid URI. And we'll want to make it more bulletproof by going in and handling test cases that really challenge the thing and try to break it. That's another thing you want to do with test-driven development, is you try to construct tests that are challenging and can break your component. That way you have a really comprehensive test suite and head off those bugs before they happen. The earlier you can fix a bug, the better. If you can anticipate it and write a test up front to catch it, that's the best. If not, then maybe later when you write those exhaustive tests, you catch it. If not that, then someone finds a bug or you find a bug, and post-mortem of the bug, of finding out about the bug, is you write the test to fix it, or write the test to verify that your fix works, basically. So we'll go into more testing next time and make a more complete URI. And then looking ahead in the future, we're going to be using this URI class in our web server to do a bunch of things. So we're going to be making sure the host name matches our host, and that the scheme identifies either secure or not secure, and the elements of the path are going to be used to pick the web service that's going to interpret the request and then generate a response. And then the query strings are going to end up going into eventually the code that handles the request to customize the request or the response. So it's going to be used a lot in our web server in the future. We'll be making a couple more libraries and classes that handle these bits and pieces of web server requests and responses, and then we'll be making the web server itself, which is going to be pretty fun. Be able to hopefully host that live so that people can interact with it as I'm coding. We'll see how that goes. Anyway, thank you if you were lurking, or chatting, or even if you're watching this years from now, thank you for watching, and see you again soon. Thanks.